Assalamualaikum and good day to the panels. My name is Mohammad Zaki bin Zaidi and I'll be presenting about my final year project proposal. A heads up, there is a minor changes on the title. So this is the title that I'll be doing, Computational Study of Flow over a Flat Plate with Riblets. Before I begin, I want to thank to my supervisor that have been helping me in this final year project. And now let's begin. Before we go deep into this, a quick summary. This presentation is about the study of flow over a transverse groove or riblets inspired by dolphins and sharks. The goal of this project is to apply the result from the analysis on real-life situations that will benefit humans. This project is conducted with the aid of computer software, which are CATIA and ANSYS. For the introduction of this presentation, there have been a significant amount of research on the dolphins and sharks' biological skin in order to be analyzed and implemented in our present application. Talking about the present day, the remarkable improvement in computer technology created opportunities for the growth of computational fluid dynamics (CFD). So it gives the opportunity that leads me to construct this project, which is inspired by the marvels of dolphins and sharks. Shark is one of the fast-swimming animals that lives underwater. The riblets on shark skin come in a variety of shapes and sizes. Depends on which part of their body and what kind of sharks they are from. You can see one of the riblets is shown on the top right of the slide. The riblet structure is consistent along the line of the streamwise flow. The riblets work such a way that it efficiently minimizes water drag by elevating and achieving natural turbulent flow vortices, making them as fast swimmers. However, not all fast swimmers like the shark, where the riblets parallel to the flow over its body. On another case, dolphins' riblets are perpendicular to the streamwise flow over its body, but still allowing it to maintain laminar flow over the body. You can see the example of the structure of the dolphin skin on the top right of the slide. It is hypothesized that these grooves, like bristling shark scales, help to postpone boundary layer separation over the dolphin's body. Within the grooves, embedded vortices occur, minimizing pressure drag and tending to delay boundary layer separation. On my literature review, I found some previous research on the riblets. Beijing reported there were riblets affixed on the US boats that leads them winning the 1984 Los Angeles Olympics and the 1987 American Cup. In 2010, swimsuit made from application of shark skin was banned from competitions, due boosting performance dramatically. Beijing also reported that shark skin-inspired riblets have been found to reduce drag up to 9.9%. This is also proven in YF2, where it is stated on the report that riblets can minimize drag up to 10% in water. There are also literature reviews about the conclusions on the analysis of the riblets. WRAN explains for tiny riblets, drag decrease is proportional to the riblet size. Goldstein and Tuan explains more on drag reducing performance of riblets declines as their size increases, shown by crafting a small secondary streamwise vortices around the tips of riblets by the unsteady crossflow degrades performance. T.W. Beecher stated turbulent drag reduction as a function of several size metrics such as reed spacings or groove area appears to follow a similar pattern across a variety of riblet design. Move to the riblet design. As at the right of the slide, in YF report, it concludes that L-shaped geometry provides the highest drag reduction performance but extremely complex to manufacture. For a shape like arc geometries, it increases the drag instead of decreasing it. This leads us to the V-shaped geometry, which is more practical and has a large drag reduction. Lastly, for my literature review, Bedin explains the drag associated with the energy necessary to move fluid away from in front of an object in the flow and then back in the position behind the object is known as the pressure drag. Now for the problem statement and objectives of this project. From the idea to apply the result of the project in real situations such as applying riblets at the bottom of the ships or to the whole body of a submarine. To get this result, first we need to study the effects of the riblet shapes on drag reduction of fluid in streamwise and spanwise flow. Next, to conclude the optimal riblet shapes on a flat plate. Next, scope and limitations of the project. A simplified geometry will be used in this project to study on how the riblets operates to the flow of fluid over it. An examination of the drag coefficient and flow outcome will be taken to measure. It is limited to groove perpendicular and parallel to the flow of fluid. 4 samples will be conducted: triangle shape, pseudo-sinusoidal shape, rectangular shape, and a flat plate. This project will be subjected to laminar flow by using computational approach in analysis fluid. On this slide, it shows the methodology of the project. Start by importing geometry to ANSYS Fluid from CATIA. Then meshing will be done in the software. After that, boundary renaming and selection has been done. A setup will be referred to pass channel before running the simulation. This is the 4 geometry that have been done in CATIA that will be imported to ANSYS. The setup that will be done in ANSYS are pressure base for the solver, laminar flow, a steady type solver, simple pressure velocity scheme is chosen for a solution approach, and the special discretization method is quasar base is employed to assure second order pressure and second order momentum upwind schemes. This is the preliminary result that has been shown by meshing the inclusion at a medium position based on the computer specs. The result shown that the thickening of the boundary layer is plainly visible. The result is to be analyzed and compared with the reference research. In this slide, this is a result taken from the reference journal. We can see how the velocity distribute on the triangle riblets. Lastly, what to be expected is, in comparison to the sinusoidal riblets and flat plate wall, based on the reference research, the triangle rib surface is proven to be the most effective riblet type in terms of drag reduction. That is all from me. Thank you for spending your time from the beginning and through the end of the presentation.